Hello everyone, today we're going to be working on problem 3.1 and this problem is asking us to determine the magnitude of f of 1. So it could be an equilibrium and also to determine the magnitude of f of 2, so it could also be in equilibrium. So what we're going to do is we're just going to be using the equilibrium equations to be able to find f of 1 and f of 2. So I'm going to start off with our x components. So we're going to write out the sum of our forces in the x direction have to equal 0 because for them to be in equilibrium, they have to all equal 0. So we're going to start off with our 5 kilonewtons. So if we were to draw a triangle right there, our x component would, so we are given that the hypotenuse of this triangle has a force of 5 kilonewtons. And right now, what we're trying to do is we're trying to find the x component. So we are trying to find this side of the triangle, and we are given that this angle is 30 degrees. So with correspondence to this angle, this side right here, the x component is adjacent to that angle. So we are trying to find the adjacent side. We are given the hypotenuse side. And if you guys remember, cosine is adjacent over hypotenuse. So which is why we are going to use cosine. And remember, we're dealing with our x components, our horizontal components. So remember, anything going to the right will be positive, anything going to the left will be negative, and these 5 kilonewtons are slanted to the left, which is why it's going to be negative. So we have negative 5 kilonewtons times, remember, cosine, since cosine is adjacent over hypotenuse, cosine of 30. Now we're going to move on to our 7 kilonewtons. Once again, our 7 kilonewtons is slanted to the left, so it's going to be negative, so negative 7 kilonewtons. And once again, sorry, for our 7 kilonewtons, we are given that this is a 3, 4, 5 triangle. And because of that, so that means we're trying to find the force on the side of 4. We are given the force of the side of 5. So we're going to be using the side of 4 and the side of 5. So 7 kilonewtons times 4 over 5. Now we're going to go on to our f of 2. Our f of 2 is going to the right. So it's going to be positive f of 2. Now, if we were to draw a triangle right here, we're trying to find the hypotenuse, sorry, we're trying to find the horizontal component of this, the x component. So we are trying to find this side of the triangle, and we are given that this angle is 70 degrees. So with correspondence to this angle, this is the opposite angle since it's on the opposite side. So we are trying to find the opposite side with correspondence to this angle, and we are given the hypotenuse. Well, sorry. Then we're also trying to figure out the hypotenuse side. So we're trying to find the opposite and hypotenuse. So which is why we're going to use sine, since sine is opposite over hypotenuse. So f of 2 times sine of 70. And then we're going to move on to our f of 1. Once again, our f of 1 is going to the right, so it is going to be positive. So plus f of 1, and we are given this angle right here. So if we were to draw a triangle like this, we are trying to find this side right here. and we are given this angle. So with correspondence to this angle, this is the adjacent side of the triangle. Well, the adjacent side of this angle right here. And remember, we're also trying to find f of 1, which is hypotenuse. So we have adjacent and hypotenuse. So for this one, we're going to be using cosine, since cosine is adjacent over hypotenuse. So f of 1 times cosine of 60 degrees. And we know that all of that has to equal 0. So now that we wrote out our equilibrium equation, we're going to start inputting some things into our calculator so we could start simplifying things down. So negative 5 kilonewtons times cosine 30 degrees. Remember, your calculator has to be in degrees and not in radians, because if it's in radians, you will get a different answer, and that will mess up your overall answer in the end. So if we were to plug this into the calculator, we would get negative 4.33 kilonewtons. And then if we were to plug negative 7 times 4 over 5, we get negative 5.6 kilonewtons. And then if we were to plug in sine of 70 into the calculator, we would get 0.940 f of 2 plus, and then if we were to plug in cosine of 60 into our calculator, we would get 0.5 f of 1. And then all of that has to equal 0. So if we were to move to have our unknowns on one side and our knowns on the other side, we would end up getting that 0.940 f of 2 plus 0.5 f of 1 has to equal 9.93 kilonewtons. Okay, so now that we did the most that we could with our x components, what we're going to do now is we're going to work on our y components. So this is the furthest that we could take it as of right now. This is not our answer. This is the furthest we could do, that we were able to do. So now that we're going to work with our y components. So the sum of our forces in the y direction have to also equal 0 to be in equilibrium. So once again, we're going to start off with our 5 kilonewtons. Remember, now that we're working with our y components, anything going up will be positive, anything going down will be negative. So our 5 kilonewtons are going up, so they're going to be positive. And now, for in this scenario, instead of using cosine, we're going to be using sine, since now we're trying to find the side of the triangle, which is the opposite of the triangle, and we are given the hypotenuse side of the triangle. So opposite over hypotenuse, that's fine. So instead of using cosine, we're going to be using 5 kilonewtons times sine of 30. Let me rewrite that. Let's zoom in a bit more. 5 kilonewtons times sine of 30. Now we're going to move on to our 7 kilonewtons. As you can see, our 7 kilonewtons are going slanted downwards, so they're going to be negative once again. So negative 7 kilonewtons. And this time we are trying to find the side of 3, which is why we're going to be using 3 over 5 instead of 4 over 5. So times 3 over 5. Now we're going to move on to our f of 2. Our f of 2 is going slightly upwards, so positive f of 2. And instead of using sine this time, we're going to be using cosine, because once again, we are given this angle and we are trying to find the y component, or the vertical component of the triangle. And with correspondence to this angle that was given to us, this angle is the adjacent angle. And we are also trying to find the hypotenuse. Sorry, this is the adjacent side, not the adjacent angle. With correspondence to this angle, this is the adjacent side. And we are also trying to find the hypotenuse side, which is why cosine is adjacent over hypotenuse, which is why we're going to be using cosine. So f of 2 cosine of 70. And then for our f of 1, we could see how that is going downwards, which is why it's going to be negative f of 1. And then for this, for our y component, we're going to be using sine, since we are now trying to find this side of the triangle, which is the opposite side with correspondence to the angle that was given to us. And then we are also trying to find the hypotenuse side of this triangle. So once again, sine is opposite over hypotenuse. So f of 1 times sine of 60. And remember, for it to be in equilibrium, all of that has to equal 0. So if we were to plug in some things into our calculator, we would get that 5 kilonewtons times sine of 30 is 2.5 kilonewtons. And then negative 7 times 3 over 5 gives us minus 4.2. Cosine of 70 is 0.34 times f of 2, and then minus, and then if we were to plug in sine of 60 into our calculator, we get 0.866 f of 1 is equal to 0. So that means we end up getting 0.34 f of 2 minus 0.866 f of 1 has to equal 1.7 kilonewtons. And how we got that, remember, we just moved these to the other side right here. And that is the furthest that we were able to take our y components. So now that we have these two equations, what we could do is we could input them into our calculators. And on our calculators, what we're going to do is we're going to use the function where it says to solve systems of equations. So if we were to write this out, we would have 0.940. Remember, we are taking this from our x components. And then we have positive 0.5, so that would be our next number, 0.5. Now from our y components, we have 0.34, so 0.34. And then for our f of 1, we got negative 0.866. And then our two unknowns are our f of 2 and our f of 1. And we know that both of those, remember we said that for our x components, that has to equal 9.93 kilonewtons. And for our y components, we said that that has to equal 1.7. So the calculator that I use is the TI-36X Pro. And from there, what I do is I turn on my calculator, then I press the second button, and then I press the button where it says systems to solve equilibrium equations. From there, I use the 2x2 linear equations, since this is like a 2x2. And then what you would do is you would input 0.940 in the first equation for x, and the 0.5 would go for the y, and then the 9.93 would be where it says equals to, and that's where you would put 9.93. And then for the next equation, you just input 0.34 for x, then you'd put negative 0.866 for your y, and then you want to put that to equal 1.7, and then you click enter so it could solve for you. And once you do that, you should end up getting that f of 2 equals 9.60 and f of 1 equals 1.81 kilonewtons. Can't forget that. And just like that, we were able to solve for f of 1 and f of 2. So by solving for f of 1 and f of 2, we also had to make sure that they would be in equilibrium, and we were able to find f of 2 and f of 1 so they could be in equilibrium. So once again, what we did is, if this was already set up like in a free body diagram, but if you had a more complex figure that was given to you, first what you want to do is you want to draw a free body diagram like this one right here. From there, we simply just use our equilibrium equations to solve for f of 2 and f of 1. So first we did our x components, and then we did our y components. We simplified them to the most that we were able to simplify them to. And then from there, you could input them into your calculator, or you could simply solve them by hand. And remember, these are just equilibrium equations. And once you solve for them, you should get that f of 2 is equal to 9.6 kilonewtons and f of 1 equals 1.81 kilonewtons.